Right now, as you watch this video, you're hurtling through space at over 200 kilometers per second. But you're not alone. Hidden in the darkness around us are dozens of stellar systems, some with worlds that might host life, others racing toward us at incredible speeds. Today, we're taking a tour of our cosmic backyard, and trust me, the neighbors are interesting. Let's start with the speed demon of our neighborhood, Barnard's star. Picture this. A star moving so fast across the sky that in just 180 years, it crosses the width of the full moon. That might not sound impressive until you realize this thing is 6 light years away. That's 35 trillion miles. Barnard's star isn't just moving, it's sprinting toward us at over 100 kilometers per second. In about 10,000 years, it'll be our closest stellar neighbor at just 3.8 light years away. But here's the twist. Even at that distance, you still won't see it without a telescope. This red dwarf is so dim that it's practically invisible, despite being right there. Its luminosity is 2,300 times lower than our sun. Oh, it might have a planet. A frozen super-Earth called GJ699b, with surface temperatures around -168 degrees Celsius. But here's where it gets interesting. Scientists think tidal forces could have created a warm subsurface ocean beneath all that ice. And if that's true, life could have been evolving in those hidden depths for over 10 billion years. Now let's visit the brightest star in our night sky, Sirius. But this isn't just a pretty face. Sirius is actually a crime scene. You see, Sirius isn't one star, it's two. There's Sirius A, a brilliant blue-white star 25 times more luminous than our sun. And then, there's Sirius B, the culprit. About 120 million years ago, Sirius B ran out of fuel, exploded into a red giant, then collapsed into a white dwarf, an object the size of Earth but with nearly the mass of the sun. 1 teaspoon of this material weighs about 15 tons. But when Sirius B died, it took potential victims with it. The explosion scattered the protoplanetary disk where planets form into oblivion. That's why, despite decades of searching, we found no planets around Sirius. The stellar nursery was destroyed before any worlds could be born. And here's the kicker. In about 660 million years, Sirius A will meet the same fate. For a brief moment, it'll flare thousands of times brighter. Then it'll fade completely. The brightest star in our sky will simply vanish forever. Over the next 60,000 years, Sirius will gradually approach Earth, becoming even brighter before it begins its slow drift away from us. But not all news is doom and gloom. 14 light years away, there's a star called Wolf 1061, and it's hosting one of the most intriguing worlds we've ever found, Wolf 1061c. This super-Earth sits right in the habitable zone. It's about 3 to 4 times more massive than Earth, with 60% higher gravity and a radius about 1.6 times larger than our planet. While it's colder than Earth, averaging around -50 Celsius, it's actually warmer than Mars. And unlike Mars, this world might have a thick atmosphere creating a glow all around the time, was mighty science. If Wolf 1061c has oceans, they could be vast and shallow, heated by geothermal activity and spread across relatively flat terrain due to that high gravity. The stronger gravity would wear down mountains over time, creating a smoother surface. This could result in planet-spanning oceans with shallow seas covering most of the surface. Such environments, warm shallow seas, are exactly where life emerged on Earth. Of all the potentially habitable worlds we've discovered, Wolf 1061c ranks 5th in likelihood, and it's one of the closest, at just 14 light years away. But it's not alone. It has 2 siblings. Wolf 1061b is the innermost planet, tidally locked and scorched by radiation. Wolf 1061d is the outer planet, following a highly elongated orbit that takes 217 Earth days to complete. While unsuitable for life, these worlds could teach us about planetary evolution. 27 light years away, there's a star going through a cosmic teenage phase, AP Columbae. This star is only 40 million years old. When it was born, dinosaurs were already extinct on Earth. But here's the wild part. It wasn't born here. AP Columbae was born 450 light years away, in a stellar nursery called IC2391. But a few million years ago, one of its sibling stars exploded as a supernova. The blast gave AP Columbae a massive kick, flinging it across the galaxy like a cosmic billiard ball. Now it's here, still unstable, still volatile. This star emits 4 times more energy than it should for its size, and is twice as large as physics says it should be. It contains abnormally high amounts of lithium, a telltale sign of stellar youth. It has violent outbursts that increase its brightness by 10 times. Any planet within 4.5 astronomical units would be continuously bombarded by radiation, making life impossible. AP Columbae is so young, it hasn't even settled into the main sequence yet. But it's also a window into the past. By studying it, we're watching what our own sun was like 4.5 billion years ago, during the early days of the solar system. 50 light-years away is something that sounds like science fiction. A star system with 6 stars. Welcome to Castor. From Earth, it looks like a single bright star in Gemini, the second brightest object in that constellation. But zoom in, and you'll find Castor A and B, 2 bright blue-white stars, each with a red dwarf companion, orbiting each other every 445 years, at a distance of about 110 astronomical units. Then there's Castor C, a pair of red dwarfs so close they orbit each other in less than 20 hours. Each star has about 0.6 times the mass of the Sun, with surface temperatures around 3,900 Kelvin. They're located about 600 astronomical units away from Castor A and B, taking approximately 14,000 years to complete one orbit. In 2018, astronomers detected variations suggesting there may be a brown dwarf lurking in the system, about 49 times more massive than Jupiter. If planets exist, they're most likely orbiting Castor C. Imagine standing on a planet orbiting Castor C. On one side of the sky, 2 crimson suns circle endlessly, never setting. On the other, eternal twilight lit by 2 distant stars, each hundreds of times brighter than Earth's full moon. You'd live in a world where true darkness never comes, where the sky is always filled with suns. Here's something most people don't know. We're living inside a bubble. Not metaphorically, literally. The local bubble is a cavity in space, 300 light-years across, carved out by supernova explosions between 10 and 15 million years ago. The gas inside is heated to 1,000,000 degrees Kelvin, but so thin that there's almost nothing there, 10 times less dense than the galactic average. Every star we visited today, bar every star, Sirius, Wolf 1061, AP Columbae, Castor, they're all inside this bubble with us. Right now, the solar system is drifting through the local interstellar cloud, a slightly denser region within the bubble. We've been in this cloud for 10,000 years and won't leave for another 2,000. The temperature here is 7,000 Kelvin, with a density of just 0.3 atoms per cubic centimeter. That's still incredibly thin, about twice as dense as the surrounding bubble, but far less than the galactic average. But here's the eerie part. Traces of iron-60, a radioactive isotope that only forms in supernova explosions, have been found in Antarctic ice. That iron came from the supernovae that created our bubble. The question is, what will we find when we finally go looking? Thanks for joining me on this journey through our stellar neighborhood. If you want to see more deep dives into space, astronomy, and the weird wonders of the universe, hit that subscribe button and let me know in the comments, which of these stellar neighbors would you want to visit first? See you in the next video.